When stars put on a show supernovae, stars are huge balls of hot gas that shine brightly in the night sky. They are like cosmic lighthouses guiding us through the vastness of space. They seem to last forever, but like everything else, stars have a lifespan. This lifespan can range from a few million to several billion years, depending on the size and type of the star. They are born, they live, and they die. The life cycle of a star is a fascinating journey, starting from a cloud of gas and dust known as a nebula to a fully formed star. Some stars die in a peaceful way, slowly fading away. These stars, often smaller ones like our Sun, end their lives as white dwarfs, quietly cooling down over billions of years. But others go out with a bang, in a powerful explosion called a supernova. This spectacular event occurs when a massive star exhausts its nuclear fuel and its core collapses under gravity. Imagine the biggest fireworks show you've ever seen, multiplied by 1 billion times. The energy released in a supernova is so immense that it can outshine an entire galaxy for a short period. That's how bright a supernova can be. These explosions are so powerful that they can be observed from millions of light years away. Supernovae are not just beautiful and dramatic events, they are cosmic phenomena that play a crucial role in the evolution of the universe. They are also incredibly important for the universe. Supernovae are responsible for creating and dispersing many of the elements that make up the universe. When a star explodes as a supernova, it scatters all the stuff it's made of, things like carbon, oxygen, and iron, out into space. These elements are essential for the formation of new celestial bodies. These elements are the building blocks for new stars, planets, and even life. Without supernovae, the universe would lack the diversity of elements needed for complex structures. You could say that we are all made of stardust, forged in the fiery heart of a star that died billions of years ago. This cosmic connection reminds us of our place in the universe and the incredible processes that have shaped our existence. To understand why supernovae happen, we need to take a closer look at the life cycle of stars. Stars are born from vast clouds of gas and dust, known as nebulae, which collapse under their own gravity to form protostars. Stars are powered by nuclear fusion, a process where lighter elements like hydrogen are fused together to form heavier elements, releasing a tremendous amount of energy in the process. This fusion process is what fuels the star and allows it to shine brightly for millions or even billions of years. This energy is what makes stars shine. The light and heat emitted by stars are essential for the existence of life on planets like Earth. The life of a star is a constant battle between gravity, which tries to pull everything inward, and the outward pressure generated by nuclear fusion. This delicate balance is known as stellar equilibrium. For most of a star's life, these two forces are in balance, allowing the star to maintain its size and shape. But eventually, a star will run out of fuel in its core, and the balance tips in favor of gravity. When this happens, the star undergoes dramatic changes. What happens next depends on the mass of the star. Smaller stars may become white dwarfs, while larger stars can explode in a spectacular supernova, leaving behind neutron stars or black holes.
There are two main types of supernovae, each with a different trigger. These cosmic explosions are among the most powerful events in the universe, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. Type 1 supernovae occur in binary star systems, where two stars orbit each other. These systems are fascinating because they involve a delicate dance of gravitational forces. One of the stars is a white dwarf, a small, dense remnant of a star like our Sun, that has exhausted its nuclear fuel. White dwarfs are incredibly dense. A teaspoon of white dwarf material would weigh as much as an elephant on Earth. If the white dwarf pulls in enough matter from its companion star, it can reach a critical mass and ignite a runaway nuclear explosion, resulting in a Type 1 supernova. This process is like a cosmic ticking time bomb, where the white dwarf accumulates material until it can no longer sustain its own stability. Type 2 supernovae happen to massive stars much larger than our Sun. These stars are often at least 8 times more massive than our Sun, making them true giants in the cosmic landscape. As these stars reach the end of their lives, they start fusing heavier and heavier elements in their cores until they form an iron core. The fusion process in these massive stars is a complex chain of reactions, creating elements that are essential for life as we know it. Iron cannot be fused further, so the core collapses under its own gravity, triggering a shockwave that rips the star apart in a Type II supernova. This cataclysmic event not only destroys the star but also seeds the universe with heavy elements, contributing to the formation of new stars, planets, and even life itself.
Let's imagine for a moment that a star decided to go supernova relatively close to Earth, say within a few hundred light years. Don't worry, this is just a thought experiment. Astronomers haven't found any stars near us that are about to explode, but it's still interesting to think about what might happen.
The first thing we'd notice is a sudden burst of light. The supernova would become incredibly bright, possibly outshining the full moon and even being visible during the day. This brilliant light show could last for several weeks or even months as the supernova gradually fades away.
Section 5, the light show of a lifetime. During this time, the supernova would be a spectacular sight in the night sky, changing colors as it evolves.
Initially, it would shine with a bluish-white light. Later, as it cools down, the color would shift towards red. It would be like having a new temporary star in the sky, captivating astronomers and skywatchers alike.
But the light from the supernova would be just the beginning of the story. Supernova release enormous amounts of energy, not just as visible light, but also as other forms of radiation that are invisible to our eyes. Section 6, a blast of energy. Along with the light show, a supernova unleashes a tremendous amount of energy in the form of high-energy particles and radiation.
These invisible waves of energy would spread out from the explosion like ripples in a pond. Some of these waves would eventually reach Earth. The most dangerous of these are gamma rays, which are incredibly powerful and can be harmful to life.
Luckily, Earth's atmosphere acts like a giant shield, absorbing most of the gamma rays and other harmful radiation. However, if the supernova were close enough, some of these rays could still get through. Section 7, cosmic rays, tiny particles, big impact. Aside from light and gamma rays, supernova explosions also hurl out streams of subatomic particles called cosmic rays.
These tiny particles zip through space at incredible speeds, carrying a lot of energy. When they reach Earth, they collide with atoms in our atmosphere, creating a shower of secondary particles.
While most cosmic rays are blocked by our atmosphere, some can reach the ground. Scientists believe that exposure to high doses of cosmic rays could be harmful to living organisms, potentially causing mutations in DNA and increasing the risk of cancer. Section 8, long-term effects on Earth.
If a supernova occurred relatively nearby, the influx of cosmic rays could potentially have long-term effects on Earth's environment. Some scientists speculate that increased cosmic ray bombardment could affect cloud formation and climate patterns. The ozone layer, which protects us from harmful ultraviolet radiation from the sun, could also be affected by a nearby supernova. The high-energy particles could deplete the ozone layer, allowing more UV radiation to reach the surface, potentially harming plants and animals.
Section 9, could we survive a supernova?
The good news is that a supernova would have to be extremely close to Earth, within about 30 light-years or so, to pose a serious threat to life. And even then, the effects would depend on many factors, such as the type of supernova, the angle of the explosion, and the orientation of Earth at the time. While a nearby supernova would be a dramatic and potentially disruptive event, it's unlikely to be an extinction-level event for life on Earth. Life is incredibly resilient, and many organisms would likely find ways to adapt and survive.
Section 10, searching for supernovae.
Astronomers are constantly searching the skies for supernovae, using powerful telescopes to observe distant galaxies. These observations help us understand the life cycles of stars, the evolution of galaxies, and the origins of the elements that make up our universe. Supernovae are relatively rare events, occurring only a few times per century in a typical galaxy. But by observing many galaxies, astronomers can detect and study these cosmic explosions, learning more about the universe we live in.
Section 11, the beauty and terror of the cosmos. Supernovae are a reminder of the vastness and power of the universe we live in. They are awe-inspiring events that highlight the beauty and chaos that coexist in the cosmos. While the thought of a nearby supernova might seem frightening, it's important to remember that such events are incredibly rare. By studying supernovae, astronomers are unraveling the mysteries of stars and galaxies, gaining a deeper understanding of our place in the universe. And who knows, perhaps one day, the knowledge we gain from these cosmic explosions will help us unlock new technologies and ensure the survival of life on Earth for generations to come.